Hi everyone, I'm going to talk about this week's lab, which is on paper chromatography. It's a lab on how to use this method to separate out a mixture, okay? And chromatography is basically a technique that utilizes the interaction of a sample with something called a stationary phase and a mobile phase. And depending on which phase that sample is more attracted to, that allows the separation of different components of that sample. An example is shown in this picture. Let's say I put a sample of ink that contains different components of dyes, for example, yellow, pink, and blue. If I put it on this piece of paper and leave that paper in the correct solvent, the solvent will slowly rise up. When it rises up, the different dyes will be attracted differently to the water, which is the mobile phase in this case because it's moving. And as a result, it will be pulled up by that water depending on how much attraction that dye feels towards the water. And this is electrostatic attraction. This is a polar substance attraction. So in this case, we can see that the yellow dye is attracted the least, and so it doesn't go up as much. The blue dye is attracted the most, the water, so it goes up the most. So in a paper chromatography system, the one that you'll be working on today, the mobile phase is your solvent system. The stationary phase is your paper. That's the part that doesn't move. How these samples are attracted to both paper and the solvent is what determines their separation. Okay. Now this is a powerful method because say you're interested in these three dyes, right? Once you separate them out, you can just cut out that piece that contains the dye, dissolve the paper away, and then analyze the component of the dye. You can do other experiments with it to figure out maybe the molar mass of the dye and other characteristics of that dye. Okay, that's really the reason you do chromatography, is you're able to separate out things into their pure form, or as pure as you can with this particular system, and then study them individually. A column is basically just something that looks like this. Okay, it's usually a plastic container of some sort. You fill it up with beads, powder or whatnot that's been dissolved, or silica. That's another one that people often use. That part doesn't move. And then what you do is you run through some solvent, right, to wet it. Okay, and then you add your sample. Here's the red thing, is the sample, and then you add more solvent, and by gravity the solvent now is gonna drip down into this container, right? Just the same way as the paper. Now you imagine the paper, but it's flipped upside down. Now as the solvent moves down, the different components of that sample is going to be separated based on their attraction to the mobile phase, which is a solvent, and the stationary phase, which is your beads in this case. Okay, like in this particular sample you have two different components, red and blue. The red is going to be more attracted to solvent, so it's going to come out first, and then the blue is attracted less to the solvent, more attracted to the beads, so it's going to spend more time with the beads, so it's going to come out later. Now one of the things that we can use often to identify what spot we have in a paper chromatography experiment, something called a retention factor. Retention factor, or RF, is a value that you calculate by dividing the distance that the spot travels by the distance that the solvent travels. So let's say I wanted to calculate the RF for this yellow spot. What I would do is I would measure from the starting point, which is where I originally put the sample, point to the center of that spot. Okay, so you see that I circle it and I put a dot right the center. I'm going to measure that distance, that I will call D, and then I'm going to measure another distance, which is the starting point all the way to where the water or the solvent ends. Okay, that's called the solvent front line, which has the symbol F. If I take D divided by F, I get my RF. Column chromatography, we often have an analogous quantity that measures retention, which is called retention time. And so the longer something takes, that has a different retention time compared to something that takes less time to come out of the column.